Okay, let's finish in part 2 that problem. When we solved, we had to take the second polynomial and use the quadratic formula. Now I'm going to jump from this to the final answer. And if you want to see the steps in between with clear writing, just go on the PDF file. Since we have a negative, we just pull it out and that becomes an I. And then 15 times 15 in here, so that's how we got the 15. Or not 15, well, it was reduced. But just look on the PDF file. Okay, so that was factoring and solving. Now, what happens if you cannot factor with these methods, but it's factorable? You can use synthetic division. Now, how do you know what to divide by? They will give you a factor. So you can use long division or synthetic. So synthetic is fake division, and it's used to just get your zeros, your solutions. Paulo Ruffini was a mathematician. He came after René Descartes. So René Descartes was like the 1600s. I believe Paulo Ruffini was in the late 1700s. And this method was called Ruffini's rule, that later textbook companies turned into synthetic division. There's not a lot on him. I know he's Italian, but you can Wikipedia him, and he usually is our mathematician of the month, and we talk about him. So sadly, I can't put him on the wall for you guys, but let's use his rule by calling it synthetic division. So what synthetic division does is says, okay, -2 is a solution, meaning if I substitute -2 into here, I should get 0. Here, if I use synthetic division, I should get a 0 as a remainder. So if my factor was x plus 3 and I set that equal to 0, then my solution would be -3. I'm going to do this one first and then do this one. -3, and then you start with 1x cubed. You use the coefficients, 5x squared. There isn't an x, so you put a 0. You want a number for each descending place. If you don't have one, then you put a 0 in. So you drop 1 and you get -3. You add these two together to get a +2. You multiply here to get -6. You drop them together to get -6. You multiply to get +18, and that pattern repeats until you're done. Okay, so you might not get 0 sometimes, and that's fine. That just means that this would not be a factor, but we do get a remainder of 0, so this is a factor. So our remainder is 0, our constant is -6, or 2 is x, and x squared. You always go from lowest to highest so you don't mess up, and your answer then is x squared plus 2x minus 6. Now let's look back at what the question is asking. It just said continue factoring the polynomial. Okay, so our factors are x plus 3, and can we break this up? We don't have 3 terms with a plus in the back. One is plus, one is minus. Our factors of 6 are 6 and 1. That will never give us a 2. Our factors of 6 are 2 and 3. That will never give us a 2. So I am done factoring. So this is your answer. Factor completely. The end. All right, now this is a little bit more intricate, so that's why I'm doing it second. It says why does this keep doing that? Probably because I'm waving my pen everywhere. Okay. For the following function, use synthetic division and substitution. Well, here's the beauty. If this is a solution, when I substitute, I get 0, but my remainder is also 0. So when you substitute a -2, if you don't get 0, say you got like 10, that's also your remainder. So synthetic division is also substitution. We like synthetic division better because it's like killing 2 birds with 1 stone. We are factoring and we're finding the solution. So here, if we use synthetic division of -2, then we put all the coefficients. Notice I put 0 when we didn't have an x. So drop the number, -6, -10, 20, 21, double it again, -42, double it again, +84. You get, oh, we have a remainder of 83. So this isn't a solution, but we're seeing that it's substitution. So if I substitute -2, you get 83 is what it's saying. So let's check. Let's actually substitute in -2 into this function. If you put this into your calculator or do it mental math or by hand, you will in fact get reduced to 48 plus 32 minus 4 minus, oh, you'll get 83. So substitution and synthetic division are the same thing, okay? If you're like, whoa, you're going fast, stop, go backwards and check it. I didn't do lessons for these. I have the notes filled in, and I did homework quizzes. So if that's still not enough, what do I always say in class? I say, how would we learn this if it was too much for us in class? And we'd say, we'd YouTube it. We'd YouTube synthetic division. We would YouTube blah, blah, blah. So that's what you're gonna do. All right, moving on. Long division. Long division's harder, but you gotta learn all your methods. Okay, so make sure there's a placeholder for everything. You don't have to with long division, but it will help you in the long run. And you say, okay, how does x get to 2x squared? Well, because essentially you'd be multiplying your answer with the divisor together to get this. How do you get from here to here? Well, you need a 2x. So 2x times x is 2x squared plus 12, because you have to multiply both terms. When you subtract the quantity, you will get negative 5x minus 30. Okay, how do you get from here to here? Multiply by negative 5. You will get negative 5x minus 30. When you subtract, you get a remainder of 0. Okay. They didn't ask, is it a factor or not? So it is a factor because you got a remainder of 0, but that's fine if you don't, if they just ask you to divide. Here, 8x cubed plus 12x squared plus 6x plus 5. How do you get from 2x to 8x cubed? You always just look at the front term. You need a 4x squared. Now, the textbook has you place it right over the same exponent. I don't care. Your other teachers or professors might be more particular, and that's okay. But I don't, so whatever. Okay, 4x squared times 2x is 8x cubed. I hear my toddler coming. I apologize in advance. When you subtract them, you will get 8x squared.